Hey everyone, Mr. Hauk here. In today's video, we're going to look at a collection of problems to help prepare us for a Unit 1A test. Let's go ahead and get started. In problem 1, we want to find the value of x given our right triangle to the right. So notice that x is the side opposite of the 39-degree angle. So when we think about our trig functions, we know that if we have the opposite side and the adjacent side, since 14 is adjacent to the 39-degree angle, we're going to use the tangent function. So let's go ahead and set up our ratio as the tangent of 39 degrees is equal to the opposite over the adjacent, which tells us that the tangent of 39 degrees is equal to x over 14. And now we know that we can just simply multiply 14 on both sides. And that's going to tell us that x is equal to 14 times the tangent of 39 degrees. Now let's go ahead and use a calculator to solve for x here. Remember that since we're working in degrees, to have your calculator set to degrees. I'm going to use Desmos, so let's go ahead and pull that up. And again, let's make sure that our calculator is set to degrees. Right now I'm set in radians, so I set it to degrees real quick. And then we're just going to type in 14 tangent of 39 degrees, and that gives us 11.34 after we round to the nearest hundredth, which is 2 decimal places. So we would say that x equals 11.34. Okay. Now let's look at question number 2. Question 2 says to find the value of y, and notice that the triangle is the exact same from problem number 1. So this time when we're looking at y, notice that y is the hypotenuse since it is directly opposite of the 90-degree angle. So we know that 14 is the adjacent leg to 39, which is going to make y, and again we know y is the hypotenuse. So when we think of a trig function that works with the adjacent leg and the hypotenuse, that's going to be the cosine. So we would say that the cosine of 39 degrees, and again we know cosine is adjacent divided by hypotenuse, so that means the cosine of 39 degrees is going to be 14 divided by y. And we can go ahead and multiply y on both sides. So we get y times the cosine of 39 degrees equals 14. Now we just simply need to divide both sides by the cosine of 39 degrees, and that's going to give us our y value. So again, let's use Desmos. We already know that Desmos is set to degrees, so we're going to do 14 divided by the cosine of 39 degrees, and that's going to give us 18.01 after rounding to the nearest hundredth. All right, looking at problem number 3, the sun casts a shadow with a 14-foot lamppost. The angle of elevation created by the shadow and the sun is 67 degrees. What is the length of the shadow? Well, let's go ahead and draw us a picture here. So we have the sun that's casting a shadow. So let's pretend that this is the lamppost here, and we have the sun, which is up here. Interesting picture, I know. And the sun is casting a shadow. This is the length of our shadow right here. Okay, so notice that this image creates a right triangle. So we know that the lamppost is 15 feet tall. So let's go ahead and label this as 15. And we know that the angle of elevation created by the shadow and the sun is 67 degrees. Okay, we're trying to find the length of the shadow. I'm going to go ahead and call that x. So notice that relative to the 67 degrees, 15 is the opposite and x is the adjacent. So the tangent is the trig function we want to use, since tangent is the opposite leg divided by the adjacent leg. So we have the tangent of 67 degrees equals 15 divided by x. Well, we'll go ahead and multiply x on both sides, so we get x times the tangent of 67 degrees equals 15. And then now we'll divide both sides by the tangent of 67 degrees. And we will have 15 over the tangent of 67 degrees. Let's turn to Desmos. 15 divided by the tangent, 67 degrees. And that's going to give us approximately 6.37 rather. So x equals 6.37 feet. And I'm just double checking that feet is in fact my unit of measurement. Okay. Looking at problem number 4, we want to find the measure of angle theta in degrees. So let's look and see what we have relative to angle theta here. We can see that here's theta in the bottom left corner. 5 is acting as the opposite side, the opposite leg of theta, and 9 is acting as the hypotenuse because it's directly across from the 90-degree angle. So I'm just going to label that here. This is the opposite. This is our hypotenuse. So this implies that we need to use the sine of theta since the sine is the opposite leg divided by the hypotenuse. So let's go ahead and set that up. The sine of theta is equal to opposite over hypotenuse. So that's going to tell us that the sine of theta is equal to 5 over 9. And remember that anytime we're trying to solve for an angle, we need to use the inverse trig operation. So we're going to take the inverse sine on both sides. So inverse sine of sine of theta equals the inverse sine of 5 over 9. Well, we know that on the left side here, inverse sine and sine are going to cancel. We're just going to get theta. And then now let's go ahead and use our calculator in Desmos to calculate the rest. So we will do the inverse sine of 5/9, and we get approximately 33.75 degrees. All right, so there's page 1. Moving on to number 5, we want to convert 160 degrees into radians. So let's recall that 1 degree is equal to pi over 180 radians. This is one of the formulas that we had in our notes. So to convert 160 degrees, let's take 160 and multiply it by pi over 180. This is going to give us 160 pi divided by 180, and now it's all about simplifying our fraction here. Well, notice that in this fraction, both 160 and 180 can be divided by 20. They're both divisible by 20. Okay, they can both be divided by 20. So if I divide 160 by 20, I'm going to get 8. But if I divide 180 by 20, I'm going to get 9. And the pi is going to be left over, so we get 8 pi divided by 9, or 8/9 pi. All right, for problem number 6, now we want to convert 10 pi over 9 radians to degrees. So now we're moving in the opposite direction. Well, recall that 1 radian is equal to 180 degrees divided by pi. Again, this is one of the formulas that we derived in class. So to convert 10 over 9 pi radians to degrees, we're going to take 10 over 9 pi, and we're going to multiply it by 180 degrees divided by pi. Well, notice that the pi's here will cancel. This pi in the numerator will cancel with the pi in the denominator, and we're going to get 10 times 180. Let's go ahead and cancel those. 10 times 180, which is 1,800, divided by 9. Let's use our calculator. 1,800 divided by 9. And that's going to give us 200. So our answer would be 200 degrees. All right, moving on to number 7 here. Number 7 says, use the unit circle to select all the following statements that are true. So I'm going to go ahead and move Desmos over here. We don't need Desmos for this problem. So we want to determine which of the statements are true. So Statement A says both the sine and cosine of 3 pi over 4 are square root of 2 divided by 2. Well, remember that sine is the y value and cosine is the x value. So if we went to our unit circle and we looked at 3 pi over 4 as our angle, so let's go ahead and find 3 pi over 4. Well, 3 pi over 4 would be right here in quadrant 2. And if we look at the sine and the cosine, the x is negative square root of 2 over 2, and the y is positive square root of 2 over 2. So this statement would be false, because this statement is saying both the sine and the cosine, or both the y and the x, are positive square root of 2 over 2, but we just saw that the x-coordinate is negative. So let's go ahead and mark this one with the false. Okay? And again, it's because we know the coordinate was negative square root of 2 over 2, comma square root of 2 over 2. So we can see that the x-coordinate was negative. Looking at our second statement, the tangent of pi over 2 is undefined. So let's look for pi over 2, and it's right here. Pi over 2 is the same as 90 degrees, and the statement says that the tangent of pi over 2 is undefined. Well, remember that tangent is sine divided by cosine, and sine is the y value, so 1 divided by 0 does give us an undefined tangent, so that is a true statement. Okay, so we would go ahead and circle this. However, just be aware there could be multiple statements because it says select all, so let's be aware of that. So let's continue on to statement C. Statement C says the secant of 7 pi over 6 equals negative 2 square root of 3 divided by 3. Well, let's go look at 7 pi over 6. So 7 pi over 6 we can see is right here. And remember that secant is the reciprocal of the cosine. So I'm going to take the cosine, which is negative square root of 3 over 2, and I'm going to take its reciprocal. So let's do the math over here. So negative square root of 3 over 2, that was the cosine of 7 pi over 6. Let's take its reciprocal, so we're going to say 2 over negative square root of 3. But remember that we don't like square roots in the denominator, so let's go ahead and multiply the top and the bottom by the square root of 3. This is going to give us 2 square root of 3 over 3. Let's not forget our negative. And that is true because that matches up exactly with what our statement said. Negative 2 square root of 3 over 3. So we have a true statement here. Let's go ahead and fill in that blank. All right, moving on to statement D. Statement D says the cotangent is undefined at 3 pi over 2. Well, let's take a look at 3 pi over 2. That's right here at 270 degrees. And 3 pi over 2 has an undefined tangent, but remember that cotangent is the reciprocal of tangent. So if we think of cotangent, cotangent is the cosine divided by the sine, or the x divided by the y. So if we think of 0 divided by negative 1, well, that's just 0. And 0 is not the same as undefined. So this would be a false statement. And it's a false statement because the cotangent of 3 pi over 2 equals 0, not undefined. Looking at our last statement, it says the cosecant of 11 pi divided by 6 equals negative 2. Well, let's go ahead and take a look at 11 pi over 6. We can see that 11 pi over 6 is right here. It's the same as 330 degrees. And we're looking at the cosecant. Well, remember that the cosecant is the reciprocal of the sine value. And the sine value being the y value, well, the sine of 11 pi over 6 is negative 1/2. Okay? So again, the sine of 11 pi over 6 is equal to negative 1/2. So the cosecant is going to be the reciprocal, or basically we just take that value and we flip it upside down. So the cosecant of 11 pi over 6, instead of being negative 1 over 2, is going to be negative 2 over 1, which is negative 2. So that would be true, and we'll go ahead and select that answer as well. Okay. Looking at problem number 8, use the unit circle to select the statement that is not true. Okay. So the first statement says the tangent of an angle will always be negative in quadrants 2 and 4. Okay. So the tangent of an angle will always be negative in quadrants 2 and 4. Well, remember that tangent is the sine value divided by the cosine. So for the tangent to be negative, only one of either the sine or the cosine can be negative. Well, if we look at quadrant 2, we have positive cosines, negative cosines, positive sines, which give us negative tangents. And if we look at quadrant 4, we have positive cosines, negative sines, which are going to also give us negative tangents. So quadrant 2 and quadrant 4 both have negative tangent values. Okay, so this is a true statement. Statement B, if the tangent of an angle is negative and its cosecant is positive, then the angle is in quadrant 2. Well, let's think about this here. If the tangent of an angle is negative, well, we just saw that for the tangent to be negative, it either has to be quadrant 2 or quadrant 4. That's coming from the very first statement we just looked at. So we're looking for negative tangents, but we're looking for positive cosecants. So again, think of the cosecant here. Well, we know the cosecant is the reciprocal of the sine. So if the reciprocal of the sine, or let's think if the sine is positive, then so will its reciprocal. So we want to look for where is the sine positive, because that means the cosecant will also be positive. So we're looking at quadrant 2 and 4, because that's where our tangent values are negative. And we want to look for positive sine values. Well, in quadrant 2 here, notice that all of our y values or our sine values are positive. So we are in quadrant 2. And that means that this is also a true statement. Okay. Statement C, the secant values in quadrant 2 are positive. Well, let's think about this here. Secant is the reciprocal of the cosine. So if the cosine is positive, then the secant will also be positive because it's just the reciprocal. Secant being the reciprocal of cosine. So in quadrant 2, notice that the cosine values are all negative, which means that the secant values will also be negative. So this statement is actually false, because this says that the secant values are positive in quadrant 2 when they are actually should be negative. All right, so there's our false statement. And just for good measure, even though we identified our false statement, let's go ahead and take a look at statement D. The cotangent values are positive in quadrant 1 and quadrant 3. Well, remember, cotangent is the reciprocal of the tangent. So if tangent is positive, so too will cotangent. Cotangent being positive as well. So we want to ask ourselves, really, is tangent positive in quadrant 1 and quadrant 3? Well, if we look at our unit circle, in quadrant 1, we have positive tangent values, and that's because both the cosine and the sine are positive. Remember, tangent is sine divided by cosine. And also notice that in quadrant 3, we also have positive tangent values. Again, that's because the cosine and the sine are both negative. So when you do sine divided by cosine, well, a negative divided by a negative will give us positive tangent values. So that statement is also true. Okay. Looking at problem number 9 next. We want to find the exact value of the inverse tangent of negative square root of 3. Well, let's think here. We are trying to find an inverse tangent, and we know that in order for tangent to have an inverse, it must be restricted on the domain negative pi over 2 to pi over 2. So we're looking on the restricted domain, negative pi over 2 to positive pi over 2. So think back to our unit circle here. Negative pi over 2 is down here, and positive pi over 2 is right up here, and we want to look at every angle in between. Now, just to make things a little easier to work with, let's go ahead and convert our angles in the fourth quadrant to negative angles. So instead of 11 pi over 6, this would be negative pi over 6. Instead of 7 pi over 4, this would be negative pi over 4. And instead of 5 pi over 3, this would be negative pi over 3. So now let's look at our problem again. We want to find the value of the inverse tangent of negative square root of 3. So remember that this is really like saying the tangent of what angle theta would equal negative square root of 3, where theta is in the domain negative pi over 2 to pi over 2. So we want to find an angle theta in our restricted domain that has a tangent value of negative square root of 3. So let's look at our tangent values, and right here I can see a negative square root of 3 as a tangent value. It's in the restricted domain, so the angle that we're looking for is negative pi over 3. So that means that the inverse tangent of negative square root of 3 equals negative pi over 3, which is answer choice D right here. All right, number 10, find the exact value of the inverse sine of the cosine of 2 pi over 3. Now remember that this is called a trig composition. We have an inverse trig function and a trig function, and we want to start with the inside of the composition, which is the cosine of 2 pi over 3. So let's go ahead and start there. The cosine of 2 pi over 3. Well, let's go ahead and find 2 pi over 3 on our unit circle. I'm going to go ahead and clear off this. All right, so 2 pi over 3 is right here in quadrant 2. Cosine is the x value, so the cosine of 2 pi over 3 is negative 1/2. Okay, so now that we found the cosine of 2 pi over 3, we're trying to find the inverse sine of this negative 1/2. So remember that inverse sine, well, we need to be looking on the restricted domain for sine, which is negative pi over 2 to pi over 2. So trying to find the inverse sine of negative 1/2 is the same as saying the sine of some angle theta is going to equal negative 1/2, where theta is in the restricted domain from negative pi over 2 to pi over 2. So let's look at our restricted domain. Again, here's negative pi over 2 to pi over 2. And just for posterity's sake, I'm going to go ahead and convert our negative angles. All right, so we want to find an inverse sine, or we want to find an angle theta that has a sine value of negative 1/2. Remember, the sine value is the y value. Here's the negative 1/2. It's happening at negative pi over 6. So what that means is that the inverse sine of negative 1/2 equals negative pi over 6. Which for me is answer choice A. All right, number 11. Select all the following that are coterminal angles for negative 380 degrees. Well, recall what a coterminal angle is. Coterminal angle is an angle, or two angles, or more than two angles, that share the same terminal side and the same initial side. So essentially, to find coterminal angles, all we have to do is add and subtract 360 degrees, or a multiple of 360 degrees. So let's go ahead and give that a try. First, let's start by adding 360 degrees. So we'll start with negative 380, because that's what we've been given. Let's go ahead and add 360 degrees, and that's going to give us negative 20. Okay, I'm going to go ahead and circle that, because that's one of our coterminal angles. Then I'm going to go ahead and add 360 degrees again, because remember, we can do this multiple times. So negative 20 plus 360, that's going to be 340 degrees. Okay, I'm going to continue to add 360 degrees, and the reason that I'm going to keep going is because notice that some of our answer choices go up as high as 720 degrees. Okay, so 340 degrees plus 360 degrees, we'll use a calculator to add those together, and that should give us 700 degrees. Ooh, no, we don't want that color. Equals 700 degrees. And I'm going to stop adding 360 right there because I know that if I add another 360 degrees, I'm going to be up in the thousands, and none of my answer choices are that high up there. So notice that negative 20 degrees is not present, 340 degrees is present, and 700 degrees is not present. So now let's try subtracting 360 degrees from our original angle. So now we have negative 380 degrees, that's what we started with. And now we're going to start subtracting increments of 360. So negative 380 minus 360. Let's go and pull up our calculator here. Okay, negative 380 minus 360. That's going to give us negative 740 degrees. And I'm going to go ahead and stop because notice that negative 740 degrees is right there. And notice that none of the angles are lower than negative 740 degrees, so I don't need to continue any further than that. Now for our last problem, given that the cosine of theta equals 5 over 9 and theta is trapped in between 3 pi over 2 and 2 pi, we want to find the cosecant of theta. Well, with this little piece of information right here, theta is between 3 pi over 2 and 2 pi. This is telling us that theta is in quadrant 4. The reason I know that is if we hop over to our unit circle, I'm going to erase this real quick. Notice that 3 pi over 2 is right here, 2 pi is right here, so everything trapped in the middle is quadrant 4. So we're in quadrant 4, and we know that the cosine of theta is 5 over 9, which is the adjacent leg divided by the hypotenuse. So what we're going to do is we're going to go ahead and set up a triangle in quadrant 4. And remember that quadrant 4 has positive x values and negative y values. And let's go ahead and set up our triangle. And by the way, if you don't remember if you have a hard time understanding what the triangles look like, let me show you exactly what they would look like. In quadrant 1, the triangle would be like that. In quadrant 2, the triangle would look like that. In quadrant 3, the triangle would look like that. And in quadrant 4, the triangle would look like that. So notice that the triangles that we construct in the 4 quadrants kind of looks like a bow tie. So if you have a hard time remembering, what should my triangle look like in the quadrant, the triangle that you draw, when all together for all 4 quadrants, the triangles that you would construct would look like a bow tie, if that helps you remember that. So here's our triangle. We know that theta is going to be right here. There's our 90-degree angle. And because the cosine of theta is 5 over 9, that means that the adjacent leg is 5 and the hypotenuse is 9. Now, the hypotenuse is always going to be positive for these triangles that we construct, and the adjacent legs and the opposite legs, their sign is going to be determined by which quadrant that we're in. Since we are in the 4th quadrant and the x values are positive in the 4th quadrant, the adjacent leg is going to be positive. But since the y values are negative in the 4th quadrant, whatever the opposite leg is here is going to be a negative value. So I'm going to go ahead and put a negative here just so I don't forget. Now we need to find that opposite leg, so let's use Pythagorean's theorem. So this is going to be the work for the opposite leg. So we have one of the legs, 5 squared. The leg that we're looking for, I'm just going to call it x squared, equals the hypotenuse squared, which is 9. 5 squared is 25. 9 squared is 81. We'd go ahead and subtract 25 from both sides. And this is going to get us that x squared is equal to 56. Now, when we think of 56, 56 is 4 times 14. So x squared equals, let's go ahead and say x equals the square root of 56. Again, we know 56 is 4 times 14. And we know that 4 is a perfect square, so this is saying that x equals 2 square root of 14, and 14 cannot be simplified any further than it already is. So the opposite leg is a negative 2 square root of 14. And we are trying to find the cosecant of theta. Okay, so let's go ahead and work on that. We want to find the cosecant of theta. Well, the cosecant, remember, is the reciprocal of the sine, and we know sine is opposite over hypotenuse. So the cosecant is the hypotenuse over the opposite. Well, the hypotenuse is a positive 9, and the opposite is a negative 2 square root of 14. Now, again, we don't like square roots in the denominator in our problems, so let's go ahead and multiply the numerator and the denominator by the square root of 14. This is going to give us 9 square root of 14, because 9 times the square root of 14 is just 9 square root of 14. Nothing really there we can simplify. And then in the denominator, negative 2 square root of 14 times square root of 14. Well, we know a square root of 14 times a square root of 14 is just going to be 14. Then we have this negative 2 times. So this is 9 square root of 14 divided by negative 28. So negative 9 square root of 14 over 28 is our answer. All right, guys, so this has been part 1 of our Unit 1A test review. Part 2 will be